Hello class, in this video I'll talk to you about the different mathematical operations that we can use with arrays and scalars and the difference between the two. So first let's look at the operations we could do with regular numbers in MATLAB. So if we have a equals 6, b equals 2, so we already know this is just the regular mathematical operations like summation, subtraction, multiplication, division, and exponents. So like this is just straightforward. So a plus b, a minus b, a multiplied by b, or a divided by b. So for the first case, like it will just be, it will look at the values for a and b. So that's 6 plus 2, it will give you an 8. For the second one, 6 minus 2, so that will give you the 4 and so on. So that's kind of how we do that. So this is mainly when we have one number. So now it's a little bit different when we have a vector with multiple numbers. So let's see some examples here. So we could, before we do vector with vector, or let's do first a scalar or mainly number with vector. If we are for the addition, it's the same. We just use the plus sign, so it doesn't matter which one you put first, like the vector plus the scalar, or the scalar plus the vector. The same thing for the subtraction and multiplication. And division is the same, but if you want to divide the scalar by the vector, you have to put the dot. So you will see that in many applications, like in this case for the division and for the exponents for both vector exponent to the scalar or the scalar exponent to the vector, you have to remember to add the dot before like in this case, before the symbol for the exponents, for the caret here. And we will give examples in MATLAB for each case here so that you can understand it better. If you have vectors, so vector with vector, again, the addition and subtraction, they don't, we just use plus and sign without dots. But for the other operations, multiplication, division, and exponents, you have to put the dot before the multiplication and division and exponents. And either this is for either case, like if you have two vectors x and y, it doesn't matter which one you put first. And again, this one we will see that later. Both vectors, if we are doing this, they should be at the same length. Like if they are columns or rows, they should be at the same length. So here there are some examples here, like if we have a vector with four numbers or elements with a scalar, which is one number 4. And we could do the operation like addition. We just, so it will be that scalar will be added to each one of them. So think about it like this, which is this is how we do it. So the 4 will be added to the 10, to the 20, to the 30, to the 40, which is what you see here. And that's the answer will be the 14, 24, 34, and 44. If we do the subtraction, will be the same. So this will be 10 minus 4, 20 minus 4, 30 minus 4, 40 minus 4. So if we are doing the subtraction, it will be 6, 16, 26, and 36. And we will look into more examples in MATLAB. If we have vector with vector, and again, the key here, both should be the same length. So this is 4, and y is 4, and x is 4. And we could either add them together or subtract them. In this case, it doesn't matter if you say x plus y or y plus x, you will get the same answer. So we call this stepwise summation. And x1 will be added to y1, x2 will be added to y2, x3 will be added to y3, and x4 will be added to y4. So that's mainly straightforward. So if you look at the answer, so 10 plus 2, 12, 20 plus 4, 24. And if you do the subtraction, yeah, in this case, it will be different if we do it x minus y. It will be different than y minus x, of course. But it will be done stepwise. We call that stepwise subtraction or addition. So it will be done one step at a time. For the multiplication, it's the same process, like we are using the same vector, the same scalar, so it will just be stepwise. So 10 times 4, 20 times 4, 30 times 4, and these are the answers you will get. And yeah, for this one, it doesn't matter if you put the vector or the scalar first, both will give you the same answer. If they are different length, then you will get error. So we have to do that, or if they are the same, because the number of, if we are multiplying, the number of columns should equal the number of rows. But if we want to do stepwise multiplication, like just multiply these together, we have to put a dot in front of that multiplication. So that's, if you just do it like this, that will not work, because the number of rows columns in this one should equal the number of rows in the y, but in this case it's not going to work. So just by adding that dot, we fix it. So in this case we just do stepwise multiplication, so that 2 will be multiplied by 10, and the 4 multiplied by 20, 6 by 40, which is what you see here. So again, if you forget that dot, you will get an error like the previous slide. This is another way of doing the multiplication or division. We could use a for loop. Mainly, it will just it will run. We can create another vector, which is called v, and we want that so we have the I. So we need to use a loop that change value from 1 to 4. So v1 equal x1 times y1. So that will change. Then for v2, we want it to equal x2 times y2. Remember the index here. And then v3 equal x3 times y3. And we could do the same thing for division or for exponent. So this is another way of doing multiplication that should give you the same answer like what we did with the dot, with the asterisk there. So that should be the same answer. Okay, so then let's look into some of these in MATLAB. Okay, so let's look at some examples here. So the first one, we just see the mathematical operations when we have scalars like single numbers, like a and b here, 6 and 2. So we could add them, subtract them, multiply them, or divide, or exponent. So this is just single operation. So if we run this operation, so you can see a plus b is just straightforward. So 6 plus 2, a minus b, 6 minus 2 is 4. A times b times b is 12. 6 times 2 is 12, and a minus divided by b, 6 divided by 2 is 3, and 6 to the power of 2 is 36. So that's just straightforward for if we have scalars. Now let's look at vector with a scalar. So as we saw in the other example, the 4 will be multiplied by 10, by 20, by 30, and by 40. So that's a stepwise multiplication. So we should expect to see the answer 4 times 10, so this is 40, 4 times 20, 80, and so on. So let's run it and see. Sorry, this is the addition, not multiplication. So 4 times 10 is 14, 4 plus 20 is 24, and 4 plus 30 is 34, 4 plus 40 is 44. And we could do subtraction. Let me So 10 minus 4 is 6, 20 minus 4 is 16, 30 minus 4 is 26, and 40 minus 4 is 36. So again, stepwise, and we just used the minus without a dot. How about if we use the multiplication? We should see the same thing. So this will be 10 times 4, we should get a 40. 20 times 4, we should get a 80, and so on. So let's run it. So we have 40, 80, 30 times 4, 120, and 40 times 4, 160. How about the division? So that's 10 divided by 4, so we should get 2.5. 20 divided by 4 is 5, and so on. So let's check that. So 2.5, 5, 7.5, and 10. Okay, how about the exponent? So for the exponent, we have to use the dot there. So 2 to the 1, we should get v. I mean, v to 1 to the square is 1, because this is v to the power of s. So 1 square, 2 square is 4, 3 square is 9, 4 square 16, and 5 square 25. Let's check that. So you can see this is what we got. How about if somebody forget to put the dot, what kind of results they will get? So let me erase the dot here and run it again. You can see we got the error there, so it does not work if you forget the dot. So let's make sure to remember to when you need to put the dot and when you don't need to put the dot. Okay, let's move now to vector mathematical operation. So if we have two arrays, as long as they are the same length, we could add them together stepwise, like the 10. A1 with B1, A2 with B2, A3 with B3. So we should get 10 plus 2. We should get first one should be 12, 20 plus 4, 24, 30 plus 6, 36, and so on. Let's check that. The 10 plus 2 is 12, 20 plus 4 is 24, and that's what we expected. Okay, how about we do the subtraction? So it should work too. So A minus B. So 10 minus 2, then we expect to get an 8, first one. Then 20 minus 4, we should get 16. Let's run it. So 8, 16, 30 minus 6, 24, 40 minus 8, 32. And again, for the multiplication, you have to put the dot with the asterisk there. So that's to work as stepwise multiplication. So doing that, so this would be 10 times 2. The first will be 20. 20 times 4, 80. 30 times 6, and then 40 times 8. So let's run it. So that's correct. So 10 times 2 is 20, 20 times 4, 80, and so on. And again, if you forget to put the dot, then that will give you an error. If you multiply them straight, it will not work because, as I said, you should have, if you do the matrix multiplication, the number of columns for the first should equal the number of rows for the second. So that will not work. So let's run it. And you get the error message again. Make sure to include the dot there. About the division, let's check it. So 10 divided by 2, then we should get the first one is 5. 20 divided by 4 is another 5, and 30 divided by 6 is 5. So let's check it and see. So 5, all of them, we got 5 for all of them when we divide. And if you like to test it again, just remove the dot and run it again. You should get an error message. And then the other method I mentioned to you, you could use the for loop, so it can just go through. Remember the index, like this is A1, A2, A3, and A4. For B, this is B1, B2, B3, and B4. So we could create another vector C. That's C1 equal A1 times B1, and C2 equal A2 times B2, and C3 equal A3 times B3. So we have to do that through a loop with four passes, and we can just do that like this is CI equal AI plus BI, and I again, remember, changes. First time will be 1. Second time will be 2, just go through the loop. So you have to understand how that works. And we put the C there. So let's run it. And it worked here. So C1 equal 10 times 2, which is 20. C2 equal A2 times B2. And this should also work with division. So let's test it and see 10 divided by 2. So you get 5, 5, 5 for each one of them. So that's another way. So I think it's good to understand both of them. But yeah, these are that. Keep in mind that the dot is important to remember when you need to use the dot with the multiplication. If you have vector with vector, you have to use it with division, multiplication, and exponents. Okay, thank you.